We'll start a new module, which is mathematical induction, and what we'll talk about in that module in this class is sequences. So let's define what are sequences. So a sequence is just a function, right? And its domain, right? We've talked about domain, the input. In other words, domain is the input to the function, right? Its domain is a set of consecutive integers, right? And so it's usually represented, a sequence is represented in general by, using these curly braces, and the A represent, a general symbol for the elements of the sequence, and K is the index. So K is, we're going to typically use K as the index, right? And and the sequence can, it can be any set of numbers, and you'll see that the index typically starts with 0 and 1, right? But in general, the index can be any number, any integer. Okay, so there's typically a formula for the sequence, and this is an example of a sequence that has an explicit formula that you can use to find the sequence. There's always going to be a well-defined mathematical function or formula that you can use to build up that sequence. So in this case, you can see that this is the index, and the index is given, the range of the index is given. And so you see that this series, this sequence builds up with powers of 2, right? And you start with 1, and then the next integer is 2, and so on. So when you plug in k equals 1, you get 2. Sorry about that. And when you plug in 2, you get 4, and then 8 and 16, and so on. So this is your whole sequence that is represented by this formula. Okay. And a sequence can be finite, right? So this is just a general way of representing a finite sequence, right? And it can be infinite also, right? And we'll see that a typical example of an infinite sequence is the Fibonacci sequence that we'll talk about later on. And a finite sequence is this one. So this is an example of a finite sequence. It has only 5 elements, right? So S1 is 2. So in this case, the sequence is being represented by this letter S, and K is the index. So there's only 5 elements in the sequence. And you can see the indices are 1, 2, 3, 4, 5, and the terms are 2, 5, minus 1, and 7, 7 and 8. And the 5 is the final index, and 1 is the initial index, and so on. Infinite sequence. So again, infinite sequence never stops, keeps on going on. And in this case, the infinite sequence is given by this, right? Although the sequence is infinite, but it's going to again be given by a well-defined formula. So when you plug in k equals 1, you get 1, k equals 2, you get a half, and then k equals 3, you get 1 over 3, and so on. It keeps on going on. Okay, so a sequence can be increasing, and it's simple, right? You consider any 2 terms in the sequence, right? If there's any 2 consecutive terms, if the next term is greater than the previous one, then it's an increasing sequence. So you can see that 4 is greater than 2, 5 is greater than 4, and 6 is greater than 5. So this is an increasing sequence. But there's a subtle difference which students get confused about, is a sequence can be non-decreasing also. So this is a relatively confusing term, right? But the only thing is that in a non-decreasing sequence, it's possible that there is an equality. So notice this equal sign, right? So any 2 terms can be equal to each other also, any 2 consecutive terms. You can see that for these 2 elements of the sequence are equal to each other. So we don't say that it's an increasing sequence. We say that it's non-decreasing. So that's the terminology that you need to get used to. And similarly, a sequence can be decreasing also. So any two consecutive numbers, so 5 is less than 6, 4 is less than 5, and so on. So every following number is going to be less than the previous one. Okay, and again, similar to non-decreasing, we say that a sequence is non-increasing, right? Because there can be a situation where two of the consecutive elements are equal. So in this case, the two elements of this sequence, 4 and 4 again, are equal to each other. So although the sequence might be decreasing gradually, but we don't say that it's decreasing because of the possibility that the two consecutive elements of this sequence can be equal to each other. So it's a non-increasing sequence. Another type of sequence is called the geometric sequence. So geometric sequence is a sequence that has a common ratio. So in other words, you start, let's say, with a number, you can build up. So there's no well-defined formula for this, but there's a well-defined pattern. And the pattern is that any two numbers that you take in the sequence, you divide the two, right? So 2 divided by 4 is a half, right? And then 1 divided by 2 is a half, right? These two. And 1 divided by 2 1 by 2 divided by 1 is a half also. So in other words, you can build up that sequence by multiplying each number with a fixed number. So if you multiply 4 by a half, you get 2. If you multiply 2 by a half, you get 1. If you multiply 1 by a half, you get a half, and so on. The next one is going to be 1 over 4, right? The next term in the sequence. Okay, so you just need to continue multiplying with a common ratio. Another type of sequence, the last sequence that we're going to discuss in this lecture, is the arithmetic sequence. The arithmetic sequence has a common difference. So in other words, you take any two consecutive elements of the sequence. So you can see that 1.5 minus 1, right, is 2.5, right? And so if you I subtracted these two, right? And so 4 minus 1.5 is also going to give you 2.5, and so on. So if you take any two consecutive numbers, right, you subtract them, there's a common difference. And so you can build up this sequence by adding each element with a fixed number. So in other words, you add 2.5 to 1, you get 1.5. You add 2.5 to 1.5, you get 4. And you add 4 plus 2.5 is 6.5. And so on. So you can build up this whole sequence by adding this fixed number, which is called the common difference in this case.